Let's understand this question. A ball of mass this and falls from a height this much. It rebounds from the ground to 4 meter. So it comes back lesser distance. It was going down 5 meters. It comes back only 4 meter. Okay. Find the initial potential energy of the ball. B, the kinetic energy of the ball just before the striking the ground. C, the kinetic energy of the ball after striking the ground. D, the loss in kinetic energy on striking the ground. We have to take G as 9.8. So let's do part wise. So first is initial potential energy, that is mg delta h. We can calculate, and we have to use G as 9.8. So the mass is given 10 gram. We will convert it into kilogram. We just need to multiply by 10 minus 2, and we will get this much energy. So this was a potential energy of 0.49 joules. This was the initial condition. Okay. Then the fall starts, it falls, speeds up, and all the potential energy gets converted till it reaches the ground, right, to kinetic energy. So this was our potential energy. And here we will get before striking, the kinetic energy will be this, because all of the energy, potential energy got converted into kinetic energy. So this is now no more potential energy. This is due to its speed, because it was stationary here. It was having potential energy. It speed up and it came before striking. It was having this much of kinetic energy. Okay. So the kinetic energy of the ball just before striking the ground will be the same 0.49, which was it was having at the top. Okay, let's go the uh, C part. Now this is interesting because it talks about the rebound. So after rebounding, it only goes to the 4 meter height. And they're asked like, what is the loss in kinetic energy here? First thing is the ball rebounds, but gets only to the 4 meter height. So potential energy at 4 meter height can give us the answer. Now let's see. See, we know the energy was here when it was here, the 0.49 joules. So before striking here, just above it, we got the kinetic energy 0.49 joules. Now, if there is no loss, the ball will go immediately back with the same energy, 0.49 joules upwards, and reach the same height. But it is not happening. It is only getting risen to the 4 meter. So what is happening? There is some loss in kinetic energy. So let's say that energy which was going up, what will happen to it? It will totally get converted into potential energy now. At the 4 meter height, that remaining kinetic energy is getting consumed. So whatever the potential energy will be at the top of this 4 meter height, it will be the same, the kinetic energy of the ball at this point just after the strike, because it is lesser, it is gaining the lesser potential energy. So if we find the difference in potential energy between these two, then we are able to calculate the kinetic energies also. So we will calculate what is the potential energy in case of 4 meter. That we will calculate with the same formula mg delta h, and we will get it to 0.392 joules. And the difference in potential energy, or the potential energy lost, will be the difference of 0.49 minus this. We will get 0.098 joules. And this is the same as the kinetic energy's difference or loss in kinetic energy. So it will be the same thing. Let's go to the next question. A spring is kept compressed by a toy cart. Mass is given. On releasing the cart, it moves with a speed. The speed is given. Calculate the potential energy of the spring. So what happened initially, the spring has potential energy as it was compressed, right? When we release the cart, the potential energy of the spring gets converted into kinetic energy of the cart. So we can say conversely, the kinetic energy which this cart gained, that is the potential energy lost by the spring. So kinetic energy of cart, we can calculate half mv square. We'll get it 0.003 joules. And this energy came from what? This energy came from the potential energy we get denoted by U of the spring. And then it got converted into the kinetic energy of the cart. So whatever the kinetic energy the cart is attaining, that energy is the potential energy of the spring.